The slides are working, so good. Okay, so hello everyone, and thanks for joining this session. As you can see, we will talk about a library. I choose this title because I think it would fit the topic of today. So one library per day keeps the doctor away. Basically, we will talk about a library that can be used in the healthcare sector. So these are the contents that we will try to cover today. First of all, we will define a scope, because I think defining a goal is the most important part of every activity. So we will have some data, and we will try to transform and get some information from this data. Then we will try to explore this library called MedSpaCy. We will see where it comes, why we use it, and let's say the original project. We will define how the pipelines work in the context of natural language processing. And then we will see a little, let's say, little use case. We don't have enough time to code, for sure. But we will try to see some code to build a simple task, okay? So I'll try to introduce myself as brief as I can. I work during the day as an enterprise architect. So basically, I'm the person who is in charge of speaking about technologies, exploring, doing some research and development, and I'm focused on topics such as, let's say, artificial intelligence and orchestration, so DevOps topics. I work in a healthcare company where I work since 2022. I changed my job during the COVID, difficult change. And then I founded my blog called redcode.it. This was the question. I decided to open a blog because I feel I wanted to share my knowledge about some topics that in Italian are not enough covered. And then I wrote 5 technical books for Apogeo and Epli that are 2 of the main publishing houses in Italy. The 5th is coming in May, and let's say there's a little hint in the slides about the topic of the 5th book. Okay, so the scope of today. Let's see which are our expectations and the diagnosis that we want to achieve. So our goal is try to build a system, okay, that can analyze the text to evidence problems such as medical conditions, such as treatments, such as medications about a patient, okay? We will have to deal with EHR, that stands for electronic health record. So basically, the document where practitioners and doctors describe your health status, okay? A little spoiler. I hope that none of you is sensitive, so I hope that most of you likes horror movies. How many of you like horror movies? Okay, less than I expect. I decided not to add some images that can hurt people, so I just will use the text to describe the patient conditions, okay? So I hope none of you will feel bad for this diagnosis, okay? So, this is an example of an EMR that stands for electronic medical record. It's a little bit different with the EHR because it's something really specific to a patient. The EHR is related to a citizen, okay? So this is part of the text contained. It says excision of limbal dermoids We reviewed the clinical files of 10 patients who had undergone excision of unilateral epibulbar limbal dermoids, and so on. These complications do not outweigh the cosmetic and visual benefits of dermoid excision, blah, blah, blah. Treatment of limbal dermoids may consist of periodical removal of irritating cilia. Okay, so basically, how many of you know the meaning of limbal dermoids? Okay, I see no hands. So basically, it's like having a little bubble over the eye, okay? Maybe it happens. It's not anything really harmful. But it's noisy, it's boring, okay? So we want our system to read all this text, okay? And to highlight some of these words related to this, let's say, to these categories, okay? We have excision, we have topical lubrication that are considered treatment, like how do you heal the patient, okay? Then we have limbal dermoids, that is the problem, for sure, the little bubble over the eye. And then we have some negative existence, so maybe the practitioner, while was describing the condition of the patient, can try to describe how the patient was not affected by some of the illnesses, okay? So this is like the result we'd like to achieve. So here comes MedSpaCy, that in our use case is the practitioner, okay? MedSpaCy is a library that was born just 1 year ago, so it's something really, really new. And it's a library that, as you can see, has a common name of a very known library in Python. How many of you know Spacy Python? Okay, some of you. Okay, so it's something that is really related to Spacy, sorry, but it's focused on clinical terms. Okay, so a clinical knowledge. The model that is behind this library has been trained with thousands and thousands of data that is related to clinical knowledge. So MedSpaCy can be used within Spacy just to build more complex pipelines, but it defines some custom components that are related to the healthcare, let's say, analysis, okay? So for example, I have described some of them here: the sentence segmentation, the contextual analysis, and the section detection. So one of the most important components, not only in Spacy, in MedSpaCy, but also in Spacy, is the tokenizer. So basically, you need to decompose your sentence in single words and try to retrieve each word, excluding, for example, some useless words, some useless punctuation or something like that. So the tokenizer is something that MedSpaCy comes with. Then you have the target matcher. If you know Spacy, you know that comes with a component that is called matcher, and that's it. And it's something that makes you able to retrieve some entities from a single larger text. So basically, you try to define some rules if you want to do something custom, and you can extract these entities. The last one is the sentence segmentation. Even if I know that MedSpaCy comes with another component, I will tell you later. So the sentence segmentation is something that really comes to locate clinical entities. Today we will focus on the target matcher, so we will try to build a simple pipeline to retrieve these components and have to deal with clinical entities. The pipelines. So the pipelines are basically the way we can define a more complex workload in the natural language processing analysis. So with Spacy, you have different components you can try to build together to get to a result. And in our case, it will represent the therapy. I like the metaphor of the healthcare sector. How do they work? So the complex task can be shared, obviously, in different single tasks. In this case, we have a pipeline that can be built from different single components to achieve a single result. In our case, I remember, is to get some treatments, some medications from a text, okay? So, in case of MedSpaCy, but in case of natural language processing analysis, we can try to divide in these steps. We have to pre-process our data. We have to post-process our data to get the information we want. And eventually, in the case of healthcare topic, we need to get historical evidences. In fact, I didn't mention before that one of the components, one of the most important components in MedSpaCy is the historical component. It can be, for example, if you have a report of a patient that talks about some illnesses related to parents, family, and so on, this can be useful to the doctor to make a more precise diagnosis, okay? So get the historical evidences, get the main context. It's something really important to get to the final result. Today, we don't have enough time to see all the steps, so imagine the pre-processing has already been done. We just focus on the post-processing, so we try to get the information with some custom rules. So let's try to code. I have prepared some code. It's very simple, I promise. It's in Python, so it should be very simple even to read. We will do a simple pipeline with an example that is the same of before. So we have finished with the horror images, and we will try to visualize this information. Okay, so first of all, we will have to load the libraries. We have talked about MedSpaCy, so we import MedSpaCy as main library. And then we try to focus on two different components of MedSpaCy. The first one is the NER, that stands for Named Entity Recognition. That is something, it's useful to deal with entities, okay? And we import the target rule. That is basically the target matcher component we will talk about later. Then we have visualization that, as you can see, as you can imagine, is something that allows us to represent visually the entities. And then we use two other libraries. I think pandas, if you have worked with Python, it's something really known. Pandas, it's useful, especially because in the healthcare sector, we don't always have data that comes with text, okay? Like a CSV or, I don't know, something stored in a relational database. Sometimes we have to deal with custom format data. So pandas really allows us to let's say, don't care about the format, just take the data that comes and use it as a simple data frame. The last one, that is not the least one, we import from MedSpaCy token a single component that is called span. This because, as you can imagine, in the healthcare sector, but also in other sectors, we need to standardize. Okay, so in the healthcare sector, we have to deal with, for example, with different diagnoses, different treatments, drugs, and so on. And we need to define some codes that are associated with these words. Okay, like to define a common language. With token, we will define which is the encoding that allows us to match different text from different sources using the same language. So this is the second part. We will load the model because luckily, MedSpaCy, the team behind MedSpaCy, that it's called Explosion AI, has done the major part of the work for us. They have trained a model with healthcare text, and we can use MedSpaCy load function to load this model. Then we will use this component from the pipeline called target matcher. I have introduced it before. So we will load this component. We are not in the interesting part. Here we are just loading the data. We are using pandas to read a table from this data. As you can see, we have some test data that comes with the DAT format. It's something not really common, luckily. The data doesn't have an header, so you don't have the, let's say, the first row with information. You just have some sentences. We will take just a partial of this data frame because you can, if I remember correctly, we have like thousands of diagnoses, so we don't want to analyze everything. Then it comes span. In here, we have the extension ICD-10. ICD-10 is the standard format for describing clinical entities. It's one of the most used. It's not the one, but it's one of the most used. We have even SNOMED. Basically, what someone has done for us is to associate a code for every entity in the clinical knowledge. Okay, so as we will see, we will have a code associated to some words. And let's view the interesting part. So here we are defining a target rule. We have eye protection that is categorized as a treatment. Treatment is a word that you can define. Okay, it could be a condition, medication, whatever you want. And this is the pattern. This is a very simple pattern, since you are just defining that we expect to see something like eye protection written in lowercase with this exact order, eye and then protection. Okay, it's very simple, but the model tried to, let's say, learn from this. Let's see a more complex, let's say, a more complex rule. For example, we have limbal dermoid, okay? This is classified as problem, since we have said that the bubble on the eye is not a normal condition, luckily. We define the pattern, okay? We have seen in the text before that these two words don't come always like single words. We have something before, we have something after. So the pattern is basically describing this condition where you can have eventually unilateral or bilateral before limbal dermoid. As you can see here, we have used like different operators. We have used lower to describe the lower case, in to describe different possibilities, and then we have op that comes with a regex, that is basically these two words can happen 0 or 1 time. Then we have the same for epibulbar, and then we have limbal and dermoid with the plural, okay? Once we have defined some of these rules, we can add these rules to the model using this function, target matcher add target rules. We are ready to build our pipeline and to test it. So we use the variable we defined before, the NLP, that is the model, okay, is the trained model, with our custom rules. And then for every entity in the document, if you recall, SpaCy works with the document object, let's say, we will try to print some information. The entity, if it's negative, so if the practitioner expressed some negative condition, and it's involved the family or some parents. And we will visualize this information. So this is the result of the print. Basically, we don't have any family information. We don't have any negative condition in this case. But regarding the text, this is the result. MedSpaCy highlighted excision as a treatment, limbal dermoids as a problem. There's a negative existence, and there are a lot of treatments, as you can see here. Nothing special, just a visualization, but you can imagine that there are different levels of applications of this simple pipeline. So these are the resources I just used for this simple use case. You will find in our example the dataset and the code that it's working. It's just a notebook. The MedSpaCy documentation that it's free, available, obviously. And then you can find in the third link some notebooks about how to achieve more complex results. The dataset obviously comes from Kaggle, so it's nothing custom, but just comes from one of the most one of the most big website about datasets. So that's it. I finished. I hope in time. Okay, perfect. I hope you enjoyed it, and that's it. I finished.
This is the moment. The best author, the best blog, read that.
No.
Called.
No, assolutamente. Thank you.
Serena.
I feel like in the Oscar. Okay.
I'm not totally dumb, but I can swear to you, sometimes I'm serious. I have a question. Before starting, if you want to raise hand, just to plan our friend Lorenzo, I have a question, because this talk is related to the medical sector, or pharma, healthcare, call it whatever. And we are used to know this sector as proprietary code, trademark, medicine, and some stuff like this. How is difficult and how much is important to spread the open source culture inside the healthcare?
It's a very difficult question. It's a very tough question. Let's say, I think that in different sectors, not only the healthcare sector, there's this like, there's a tons of people that are like too afraid to share the results they achieve in the company. Companies like Explosion AI have always worked with the scope to share this knowledge. Okay, so everything they've made is always full documented. They shared a lot of examples. For my experience, I know that in this sector there are too much proprietary source codes, and I think this is something maybe harmful, because especially when it comes to health, something like this could be useful, and I don't know, maybe for people that live in the other side of the world. So I don't know. I cannot speak by myself as a, let's say, an employee of my company, because we have done in the past years different open source projects. But I hope we will do more, let's say.
Do you know other big contributors in the healthcare market with other cool solutions like this?
No, actually, MedSpaCy, so Explosion AI, it's one of the most important one. In the healthcare, we don't have enough projects about the, let's say, clinical topic.
Okay.
Question right here.
Question?
Yeah.
Okay.
Hi. Thank you for the talk. And thank you for talk about data science and AI, because in this kind of conference there are not too much, so it's better. And I have a question about the model.
Okay.
So it's made by a knowledge graph, something like an information retrieval model, or there is a transformer?
Okay, in the case of the, let's say, the use case I've used, this is based on the pre-trained model from MedSpaCy that is based on neural networks.
Okay.
I didn't have used transformers for now because the use case should be very simple. We just have 25 minutes. But if you use transformers, you can highlight the result really up to the sky, let's say.
Are they inside the library?
Yeah. You can use even the transformers that come with MedSpaCy because they are like included, and MedSpaCy offer more transformers that are focused on the clinical knowledge.
What about instead to choose a knowledge graph or a retrieval model like entity recognition, tag me? There are many models about retrieval, so it's more cheap, less resource. And so transformer is big, neural network is big. The retrieval model is more mathematical stuff, nothing.
Yeah. Your assumption it's true, it's correct. And in fact, in the clinical knowledge, the graph modeling it's used when you have a defined standard, as the one I've used, the ECD10. Sorry. This is perfect because it can connect different entities and you can even do predictions using the graphs. So this is something you can definitely do. We have different projects using the FIRE standard that use the graph. So it's a good point. You're welcome.
Thank you very much. Let's give a round of applause for Serena if there are no more questions. Well, I mean, the round of applause. Yeah.
Grazie.
Amazing, Serena.
Oh, we have a question. No, wait.
Grazie.
We do have one. Wait.
I have.
The
Sorry.
last amazing question.
Okay.
What about your book coming in May?
Okay, so the slides were like blue, light blue. So can you imagine a technology where the logo is blue? That doesn't have to deal with artificial intelligence.
Does it live in the sea?
Yeah.
I guess so.
Yeah. But it's the pilot in this case.
Okay.
Okay?
Thanks again, Serena.
Thank you.